Inversion. Inversion.
Welcome to clickmyproject.com. Our project title is Techniques to Minimize State Transfer Cost for Dynamic Execution Offloading in Mobile Cloud Computing. In our project, in order to meet the increasing demand for high performance in smartphones, recent studies suggested mobile cloud computing techniques that aim to connect the phones to adjacent powerful cloud servers to throw their computational burden to the servers. These techniques often employ execution offloading schemes that migrates a process between machines during its execution. In execution offloading, code regions to be executed on the server are decided statically or dynamically based on the complex analysis on execution time and process state transfer cost of every region. The main aim is to predict the large number of resources from each node. Experimental results shows that static partitioning can greatly reduce energy consumption while satisfying the cost and time constraints with guaranteed confidence probabilities regardless of different network bandwidth. Expectedly, the transfer cost is deciding factor for a success of execution offloading. According to analysis, it is dominated by the total size of heap objects transferred over the network, but the previous work did not try hard to minimize the size. So we have to introduce a new techniques based on compiler code analysis that effectively reduce the transfer data size by transferring only the essential heap objects and stack frames referenced in the server. This algorithm has a lower time complexity and good performance is presented in the paper. The experiment result shows that the performance of parallel simulation is improved with this scheme and partitioning algorithm. The experiment exhibits that the reduced size positively influences not only the transfer time itself but also the overall effectiveness of execution offloading and ultimately improves the performance of our mobile cloud computing significantly in terms of execution time and energy consumptions. As their processing capabilities, smartphones are rapidly becoming the computing device of preferences that can accommodate most up-to-date mobile applications. Moreover, to minimize device fragmentation, virtually all smartphones adopt cross-platform runtime environments such as Java, ME, .NET CF and Android to develop and run applications. The basic idea is to let the devices, computations and energy on cloud servers to execute mobile code that requires heavy use of computing or network resources. First of all, it seems obvious that mobile computing can accommodate a much wider range of complex applications which have been impractical to run solely on smartphones such as perception applications, versions, graphics, etc. As another advantage, mobile cloud computing may relax the design constraints of smartphone hardware which, due to the considerations of size, cost and battery capacity, have been strictly imposed on hardware requirements or hardware features like CPU, storage and network cables, etc. with mobile cloud computing. It's our data flow diagram. First of all, we are going to create and we are going to configure each and every node like user informations and also virtual machines, cloudlets, cloud brokers, like that. So then we are going to provide each and every ID to each and every users, each and every cloudlets and also virtual machines. Then we are going to calculate the maximum capacity of each and every virtual machines to do the given job or to work out the given job. And then we are going to send a file to each and every virtual machine. File is nothing but a job. So the each and every virtual machine could be calculated, could be done successfully a job which is given by the server in a virtual machine. So finally we are going to compare the calculation cost that is performed by each and every virtual machines. So by comparing each and every cost, which virtual machine could be executed the given job at the minimum amount of time, that could be analyzed and that could be displayed. So these are the new techniques that we are proposed to minimize the cost by passing the essential heap object and stack frames actually preference in the server. Let me see the demo of our project. Choose home1.java, then click run file to run from the beginning. It's our home page. Just click on it. It's a declaration page that we have to declare how many number of data centers that are needed to perform the given job, and also how many number of brokers that are needed to transfer the data from data centers to the data cloudlets. Its users is nothing but how many users that are going to give the jobs to the data centers. Mobile station is nothing but these are all the operations that could be done on this mobile station. So we have to declare itself. Next, in this frame we are going to create an individual ID for each and every data center and each and every cloud brokers, users, cloudlets, and also for mobile stations, because we have to identify which data center could be accessed by the broker and also which job could be executed by the virtual machine. So these are all the IDs could be provided for each and every data center, and also these are all the IDs could be provided for each and every cloudlets. Then mobile station could be generated, because all operations or all jobs must be executed in these virtual machines. Cloudlet is nothing but it's a running process in a running server. Because of the help of Cloudlet, we are going to process the job. Then next, load prediction is nothing but we are going to analyze or we are going to compute which virtual machines or capacity of each and every virtual machines. The virtual machine ID could be displayed here, and the bandwidth, how much speed it can be taken to perform a given job, and also its a cloud length and current load. Then this information could be displayed for each and every virtual machines. Then we are going to cost compute. Cost compute is nothing but how long it takes to execute a given job at a time for virtual machine 1 and for virtual machine 2. Then we are going to schedule the job. We are going to click execution. At the time of execution, what are all the process or what are all the tasks that are going in your system currently that are going to be taken as a job. So it performs each and every job sequentially, and finally it could be displayed how much of job and how many job it could be executed. In this, these are the host ID. It could be total allocated space could be displayed here, and the requested space could be displayed here. So they are all run in each and every virtual machine. So by comparing those among one by one, which one could be get the minimum amount of data or minimum amount of time that could be selected. Then output, there are 50 number of hosts could be executed in 2 virtual machines. So the total simulation time could be displayed here. So this will be the energy consumption. In a graph, by comparing with expected, achieved could be greater than expected. By comparing it will be the FB reader. FB reader is nothing but existing system. In existing system, it takes large amount of data, but it could be transferred at a time of essential heap object and also with unwanted information with the heap object. So it could be less. So, but in our proposed objects, we transfer expected or else essential heap object must be transferred. So we are going to minimize the energy consumptions in the network. Thank you.